Good.
راح يكون مع نتمنى انكم استمتعتم في الاجازه اجازه يوم الجمعه ويوم السبت. زملائنا من خارج البلد زاروا اماكن مختلفه، ذهبوا الى ابو ظبي وشارقه ودبي، واليوم زرنا دار الشيخ سلطان من الساعه 10 الى 12. الان نستمر مع المحاضرات القيمه من المدرسه الشكليه الدوليه للطلبه الدراسيه التي ينظمها مؤسسه الشارقه الجديده للعرب والمسلمين في دوله العربيه بالتعاون مع المؤسسات المختلفه، ونشكر تدريب الشارقه للعلوم والفلك والفضاء والتكنولوجيا الذي استضافتنا في هذا المكان الاسبوع الماضي واليوم وغدا. اليوم المحاضره الاولى او الجلسه الاولى سيكون محاضره الاستاذ الدكتور الياس كرمي بعنوان تاريخ الجوانب الفريده المميزه في العلوم الفضائيه وعلوم الفلك والفضائيه الاسلاميه. استاذ الدكتور الياس كرمي هو نائب المدير العام لاكاديميه الشارقه لعلوم الفلك والفضاء والتكنولوجيا والجديده جامعه الشارقه. تفضل استاذ.
شكرا. Thank you very much. So usually I cannot stand on the podium and talk, so I need to move on. I believe my voice is high enough for all of you, and hopefully that my English is good enough. If it is not good enough, we'll turn it to French. I believe it will be easier pour moi de parler en français parce que le français pour moi c'est ma langue maternelle. What did I say? I don't know. Whatever. So I will talk in English. And if there are any Arabic words I can pronounce, I will pronounce. I am from Algeria. I am Muslim. I am an Arab, whatever, Amazigh, whatever. So we are all mixed these days, whatever. So this is the story of my interest in this field goes back to the 80s when I went to the US to study astrophysics, to get my MSc and my PhD there. And I was very keen interest into the history of Islamic science, because as you know, whatever book you open in mathematics, in chemistry, in physics, in astronomy, whenever they talk about the history of that subject, they will not spend a lot of time, a lot of pages in that field. They may just write one paragraph about the Islamic contribution to science, and that's it. But for sure, you cannot summarize 11 centuries of Islamic science in just one small paragraph. That's why each one of us has a duty to talk about it, depending upon his or her expertise. I am in astrophysics, physics. I will talk about it. Maybe someone in chemistry, someone in biology, because I believe the Islamic contribution to science is not small. We came after the Greek science, and for sure we did not just copy that science. For sure, enrich it, and that's why it is good to talk about it. So I will expose that to you as we move on, inshallah. And if there are any questions, so please feel free to ask questions. Okay. Usually it's good to have this kind of straight whatever. Okay, so let me see if this pointer is working. If it is not pointing, I brought my own pointer. Okay, it is not pointing. I don't know. So it is working over there. So is it on? Yes, it is on, mashallah. Okay, I need to be there maybe, or maybe this is the battery is dead or whatever. Okay, Jamil. So I did attend last year third SIFHAM winter school, and I showed this picture. This is a beautiful one because usually I ask my students, what does it represent? Some of them right away they jump. This is the Arabs. No, the Arabs before Islam were nothing. They were killing each other. They were killing their daughters and their sons. The Arabs were nothing. It is Islam that brought them to the top level. So this is what you call the Islamic empire. There's no Arabs in it. There's no Arabs because if it weren't for Islam, will be nothing today. So this is the whole Islamic empire. I go from the far east to the far west, and each of these cities that you see as points were just centers of knowledge. So if I may go here, so this is Toledo, Cordoba, I go to Ishbilia, I go to Fez in Morocco, I go to Qayrawan in Tunis, I go. All of these cities were centers of knowledge, and there was, I'm sorry, I went too fast. There were great competition, not in terms of which country has the tallest building, which country has the tallest, or which king has the tallest, whatever. No. It is about how many books you have in Cordoba, how many books you have in Samarkand, how many books you have in Baghdad, in Isfahan. So this was the real competition. And the cities over there were competing in terms of who has the most number of scholars. Yes, the scholar. This is what a real competition. That's why we need to be very proud of it. And if again just take a glimpse of this slide. This is not all the scientists. Okay, and this is a mixture of what? Of Muslim scientists, Jewish scientists, and also Christian scientists. They did work under one roof. I believe yesterday or maybe the day before you visited the house of wisdom, Dar al-Hikmah, yes. Well, some of these were under Dar al-Hikmah that saw the beginning of the Islamic civilization. It was the beginning of something that we cannot forget. Golden names, forgotten civilization. The Banu Musa, when I talk to my students, especially the engineers, do you know the Banu Musa? You as an engineer, you know, so you're not an engineer because this is Banu Musa, three brothers, engineers, mashallah. Ibn al-Haytham, the father of the optics, Abbas ibn Firnas, for sure. Everyone knows Abbas ibn Firnas, the one that tried to fly 600 years before Leonardo da Vinci. Alhamdulillah, he did not die, so he tried to fly, so he was alive, mashallah. But this is good. And Al-Kashi, without Al-Kashi, we won't have our computer today, mashallah. Abu Ma'shar was a Jewish. Don't worry, I'm doing this because we're going to change it to an LED panel. That's why if I break it, that's why it will be good. So we're going to speed up to change it to an LED panel, mashallah. We have the money to do it. Instead of spending it in food, we spend it in something good, mashallah, LED panel, mashallah. So Abu Ma'shar was a Jewish, was a very, very well-known astrologer. They say that at the end of his life, he became Muslim. I have no idea. Ibn Shatar, yes, when you talk about Copernicus, when you talk about the heliocentric system, we should not forget Ibn Shatar because he has, even though it is a little bit controversial today, as Dr. Andreas may say about it. So, but he did put a model about the motion of the moon around Earth, and his model is completely identical to Copernicus, and between Ibn Shatar and Copernicus were 150 years, 150 sana, بمعنى there must be some kind of transmission. And for sure, we know that Copernicus spent about 10 years in Italy studying the Islamic manuscript, and we know that in his hometown we found a book of Ibn Shat or whatever. So there are so many disputes. Nasruddin al-Tusi is very, very famous. Why Nasruddin al-Tusi is very famous? Why he was a full scholar. This is what he called polymath. It's not like today, you know, only one field and anything else is difficult. But these are polymath. They knew everything. Where Nasruddin al-Tusi was, besides being a scientist, was also a very keen politician. If it were not for him, okay, we won't have this this Maragha observatory, because the Mongols were going to destroy it, and he came to the Mongol chief in order to save his observatory, and the Mongol chief found in Ibn Nasruddin al-Tusi found a very, very good politician. He did not destroy the Maragha observatory, and he did help him to build it. So this is history. Abu Wafa, Ibn Yunus, all these are what we call golden names, but forgotten. So this is now my talk. I didn't start yet, but as just a content to guide you with my lecture. If you are tired, tell me, please. Tell me if you are tired. Tell me that you are tired of my shouting and so on. I will give a short historical background. Okay, how things started. Okay, the unique aspect of the Islamic science. This also be one point. The major importance for astronomy. You may know them if you are Muslim. You would like to pray. You don't pray as you wish. If you would like to fast, you don't fast as you wish. So we have some guidance, and this guidance did help the development of the Islamic science. Major schools of mathematics or astronomy. This is a little bit technical. I may pass through. Major Islamic observatories. This is very important. Yes, you may have heard for sure of the James Webb Space Telescope. Whatever. So it is a big space telescope, like the Hubble Space Telescope. You may have heard about the Hubble Space Telescope, mashallah. It is at the end of its year. That's why we have the James Webb Space Telescope. Well, you must know that the observatory started with the Muslims, yes. Then it went to the to Europe, yes. We'll talk about it, inshallah. Then the decline and hopefully the rise to the present. And this is what I believe every Muslim country is doing, like to revive the Islamic sciences. And that's a duty upon all of us. All of us, we are responsible for it. You don't say it doesn't concern me. No, it is the responsibility of all of us. So I would like to talk about all of this, hopefully, in the coming 1 hour, 1.5 hours, and so. Today is a very busy day for me. I had 2 sessions. Teaching at 8 o'clock, then 9:30. I had a meeting with the chancellor at 11 o'clock, meeting at 12 o'clock, you at 1 o'clock, meeting at 4 o'clock. My wife, when I go to her, I am flat. Okay. The language of modern science, we can say for sure, has its root, judurihi, in what? In so many Arabic words. You cannot escape this fact. Whatever you pronounce, so this name has its root. If I take just star names, Betelgeuse, 1 star in the constellation of Orion, Yad al-Jawza. If I talk about Taurus, Aldebaran. If I talk about Pisces, Fomar, it is a Fomar, Hofumul-Hut. It is an Arabic name. So there are so many. So the modern. So like for example, just algebra, algorithm, zenith, Samtani, Nadir, Al-Qadi. So all of these have a root in the Islamic Arabic science. Okay, and the heart of science. What does it do? What does it do? So, for example, no more than mathematics or physics without algebra. You cannot do physics or whatever if you don't know algebra. Okay. Like if I take as example, Khawarizmi fi kitab al-jabr wal-muqabala. So how to write your equation, x plus 1 equal to 2, how to solve it? Well, you have to think whom? You have to think al-Khawarizmi. It is said that for the algebra, we, the Arabs, we brought these numbers 1, 2, 3, and 4, and 5, and 6, and now we added 0. And I will joke about it. I wish we did not discover zero, because since we discovered zero, we became zero. So that's why, so we need to be a little bit careful. No computer without algorithm, and also no chemistry without alchemy. So these are the root of the Islamic science. So this is very important. But للأسف, as we said, we Algerian لا غالب, I believe. I don't know how to say it, لا غالب in English. How to say in English, لا غالب. الله غالب على أمره. Whatever. Okay, so, but very few people, even scientists in the West, are aware of this medieval Islamic legacy. It's like if we did not exist. And that's too bad. So we'd like to bring it into light. But it wasn't always so. Alhamdulillah. There were some centuries where there was some kind of awakening of these Islamic sciences. And that's why we have it, I was told that it is a problem, so let me check it. I can put it here. It goes here. Sorry, Doctor. Yeah, there's a problem with it, so hopefully I'd like to tear down my tie. It is okay. Zuber is not here, whatever. Okay, so we'll see it here. Can you check if the audio is good for the Zoom? Out of my time. In my pocket. Okay, check if the audio is good. Okay, good. Sorry for this. So between the 12th to the 17th century, thanks to God, so some European scholars, they did refer to some Islamic scientist texts. That's very good. The Arabic names were part of the medieval text. That's excellent, especially in astronomy, math, optics, and medicine. A good example is Al-Khawarizm. So I believe his manuscripts or his books, his works, and they were used for centuries. Why? Because it was about algebra. And as I said, you cannot do anything without having that knowledge in mathematics. That's why. So it was something that was very, very crucial for those people in this 12th to the 17th century. That's why Al-Khwarizmi is very, 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 very well known. So this. Okay, so I have to check again. Okay, so there's one very, very important development, the introduction of the decimal point. I believe today you cannot imagine yourself writing a number without a decimal point, because you cannot do it. So you go shopping, they will tell you it is 9.99, tell you 10, whatever, but it is 9.99. So that's 9.99. It is, so that's why this decimal point was primordial in terms of the development of mathematics and so on, because we are so familiar to it. And today you look at it as something simple. How come it was a big discovery? But it was. Yani. That's why we take it for granted. Okay, so I finished with the introduction. Now let me go to the second point: the unique aspect of the Islamic side of the. I'm sorry, I'm going backward or forward, whatever. Whatever. Okay, so. What is good that in the development of the Islamic science in the early centuries, so the rulers were very, very conscient about building their own societies. What do you mean by that? For some rulers, having a mosque is fine, but having hospital is fine. Having some kind of observatory is much more fine, because for the observatory in those old days, it was responsible for setting everything, for setting the Islamic prayer times for setting the beginning of the Islamic month, for setting the direction of Qibla. So it was something very, very important for them. That's why in the early days, so this was a very, very big concern. So whoever comes to power, this was his or her duty. For example, having a library was very important. Having a hospital, having even an observatory, it was also very important, because the observatory was like a part of the state institution. It's not like today, so you have to ask for fund and so on. So for some practical reasons, so these sciences were very, very much developed, especially in terms of medicine can save our lives. Some military technology can win wars, and mathematics could help the Islamic empire with finances, with heritage, and so on. So it was a very, very, very big concern. Astronomy, for example, here in terms of as I said, finding the right direction for the Qibla, finding the right time for the prayer times, finding the right beginning for the Islamic, for what you call for the Islamic month, especially for Ramadan. So this was very, very, very important. But one point here, that at the beginning of Islam, so there were so many different ethnic backgrounds with different language. That's why Arabic came into rescue. That's why Arabic was for more than 11 centuries was the language of science. You would like to do science, you need to learn Arabic. And as just one example, if I take the Samarkand Observatory, students were coming from Europe before they reached Samarkand, because Samarkand had this, what you call this madrasa, built by Ologbek, the ruler of Samarkand. He also built an observatory. So before they come there, okay, they need to know Arabic. Arabic was the language of science, and that was very, very important. I believe Samarkand was the first school. It's not school like a madrasa. It's not like school, whatever. It was like some kind of university where students will come, and he or she will be taught all languages, all sciences, not only astronomy, but astronomy, mathematics, physics, and everything. That's why. So the Arabic language was the one that did help to unite all of this Muslim ummah, because for sure Arabic is the language of the Quran and so on. So it became the daily language, as it is today English. So English is the language of science as we know it, and no one is going to deny that. So it became the language of the Islamic culture. So wherever you go from east to west, Arabic was that language that you allow you to speak to everyone in the surrounding. That's why all of the old manuscripts from different languages were translated into Arabic, and this where the house of Hikmah comes into light. It was very important to have all of this translation being done in Arabic. So the rise of the Islamic science, so it's apogee between the 8th century to the 15th century. So all of the, as I said, all of the manuscripts were translated into Arabic. That was very important. We had what you called this house of wisdom, okay, and Baghdad became what you called the city of science, okay, as it is today. There are so many Western capitals, the city of sciences, and so on. So it was like the beginning of the Islamic science, and also for sure, as I said earlier, that every part of the Islamic empire wanted to be a center of excellence in terms of gathering the highest number of scholars in all fields, publishing the highest number of books around. Just to give you an example, if I compare, let's say, Cordoba in the 12th century, its library had more than 600,000 books. Do you believe that? Cordoba in the 12th century had more than 600,000 books. At the same time, 12th century in England, the large library that did belong to a church had only 5. Why? Because the Muslims saw in the paper that was brought from China a way to communicate. But in the old Europe, so they were still using what you call the animal skins, and so that's why it took some time to develop the library over in Europe. So So the main thing that the Islamic science now has reached from the Far East to the Far West. When I say to the Far East, I go to Samarkand. When I go to the Far West, I go to to Spain and so on. So there were so many personalities. I won't go through each one of them in detail, especially if it is far away from my field. So we have like Ibn Sina in medicine, Biruni for sure. Biruni is how to say it? Biruni is what you call the master. The master. He wrote more than 180 books in all fields. He wrote 11 books in what you call now. We call it حساب المرتفعات. We got in English geodesy in the 11th century, and this field appeared in Paris in the 19th century. Al-Biruni is said to measure the specific weight of 18 minerals. 18, when you talk about specific weight means that he knew a little bit of gravity. Yes, he did not formulate the law of gravity as did Newton, but at least he has some knowledge about it because he was able to measure the specific weight of 18 minerals. So he has some knowledge, the master of all the masters. So he knew almost everything. Okay, Ibn Yunus, Ibn Umar al-Khayyam, and we talk to Ibn al-Haytham. So if we go to the Andalus, we have Ibn Rushd, we have Ibn Zor, we have also some other scientists. Then we go to the 30th century, we have Nasruddin al-Tusi and on the astronomer of the Maragh Observatory. And then we go to the what you call the 14th century when we have the Samarkand Observatory, or what you call the Madrasa of Samarkand. So there were so many development in this. So what are now the unique aspects of this Islamic science? There are four main aspects. The first one, scientific institution, like the observatory, like the libraries, like the universities. Yes, this is just one aspect. The other aspect, Muslim polymath. So you take al-Biruni, you take al-Battani, you take, they were specialists in everything, almost everything. So they knew almost everything. They wrote, when I say they knew almost everything, meaning that they wrote in every field. In every field, they have tens of books. That's what I mean by Muslim polymath. Also, scientific method. So this they brought to us the way we do science. So how do we do it today? The scientific method. Well, you may have a problem. You may, like for example, I say it in my field, astrophysics. I may observe something. How I'm going to check it? Well, I will build a model based upon what? Based upon my my knowledge of physics, my knowledge of mathematics. So that model, that theory, may predict other things. And what I will do, I will go and try to observe this prediction. If I do observe this prediction, it means that my model is good. So I may need to change it a little bit. If my observation, if my model does not satisfy this prediction, meaning that I have a wrong model, I will work it out and I will do again. This is what you call the scientific model, which means what? It is an ever going loop. It will never stop. You always go around. You are going to tune it, because if it does stop, it means khalas, there is no scientific method. So it never stops. You always tune up your model to make more predictions, and your prediction for sure have to be observed. Otherwise, you have to redo everything. And also the peer review process. Well, this was done, especially in medicine. In some hospitals in the 11th, 12th, 13th century, a doctor, a physician, does not do things as he does wish. No. He may have someone, so he may have someone sick, and he will make his diagnostic, and he will discuss his result with other physicians. This is peer review before giving him the treatment and so on. So this is this part of this main aspect of this Islamic science. So this is very, 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 very important. Well, talking about scientific institutions, what are they? There are so many So many. The first one are the public hospitals. The public hospitals with running water, that's unbelievable. You're talking about the 8th, 9th, 10th, and 11th, 12th century. Running water like today we have in our hospital. This is very, very important. Also look at it here, psychiatric hospital, do you believe that? They did exist, okay? Public libraries and lending libraries. Public libraries, as I said, Cordoba, 600,000 books, mashallah. So it was an institution. The academic degrees, okay, especially I give one example. Samarkand was giving a degree. So you may spend 1 year, 2 years, and after you graduate, they will give you a degree that for sure your teacher was Ologbir. By the way, Ologbir is a polymath. He was a scholar. He was a ruler, but also a scholar. Okay, there's a very bad story about Ologbir, but after building his Samarkand observatory, at the end he was killed by his son. His son wanted to take power, and that son did order the destruction of the Samarkand observatory. It was only in 1971 that some ex-Soviet scientists were able to find the ruins of the Samarkand observatory. Only 1971, do you believe that? And now it is a touristic site. So if you go there, so you can see it. And also, as I said, astronomical observatories. So these were the backbone of this Islamic civilization. It was not built upon nothing. It was built upon this beautiful institution. Well, I don't want to spend time talking about this. We call them universal geniuses. They are universal, yes. Compared to us now, polymath, Al-Biruni, I talked about him, Al-Jahiz, Al-Kindi, Abu Bakr Al-Razi, Ibn Sina, Al-Idrisi, Ibn Bal. Well, Al-Idrisi, this beautiful geographer, do you know he was kicked out by Muslim rulers. He didn't want him, I don't know why. So that's why he went to France. And the King Roger asked him, can you build me a map of the world? He said, yes. And that map now is called the King Roger world map. It was done by Idrisi, mashallah, whatever. Okay, so there are so many beautiful names. Omar Khayyam, so let me go through some of them. Ibn Zar, Ibn al-Khawarizmi, Ibn Musa, Abbas ibn Firnas, Nasiruddin al-Tulsi, Ibn Khaldun. Unbelievable. These are unbelievable. These are beautiful names that, yes, you hear about them, you may know them, but you don't know that these are the people who wrote the history of the Islamic science. And there are tens and tens is more. There are hundreds and hundreds of their manuscripts in some European libraries. Why? Okay, so in terms of the scientific method, so Muslim scholars, they build a great emphasis on experimentation than previous one. And I will not try to explain everything, but for science to flourish, especially in the field of astrophysics, which is now mainly built upon observations, because we have some great observatories in space. So observation is very important. So this is part of what you call you know something that is happening, I would like to explain it. And the best way to explain it is to build for it a theory. And that theory, you have some either ground observatories, space observatories for you to check it out. And that's why, so observation in every part of science is very important. Here I wanted just to cite some best examples of this scientific method and how it was applied in these different fields. If I take as an example of Ibn al-Haytham, empirical observation in optics. Ibn al-Haytham was very important scientist for let's say for Roger Bacon, because all of what Roger Bacon did and in his optical work in physics was based upon Ibn al-Haytham, as they call it al-Hazm. Jabr ibn al-Haytham, Jabr as in chemistry, Al-Bukhari in the history of science and hadith, as all Muslims know, Al-Kindi in earth sciences, Ibn Sina in medicine. So for every type of science, there is a very, very well-known polymath that did distinguish himself. I say himself, but for sure, there's also herself, because there are also some female. One time I was giving a seminar here at the American University of Sharjah, and one lady told me, you talk only about male Islamic scientists. How about our female? I say, yes, we have. We have a bunch of them, mashallah. And in this coming Saudi Arabia conference, Aisha Al-Awis is going to talk about the female contribution to science. Yes, we have some very, very famous. I'm not whatever, but whatever. Okay, so we have so many good examples. This is just an example of the scientific method of Ibn al-Haytham: observation, statement of the problem, formulation of the hypothesis, testing of the hypothesis using experimentation, analysis of experimental result, interpretation, publication. This is exactly what we do today. Exactly. This is exactly what we do today. So to do science, to publish, this is the way you do it. This is the scientific method. Well, this has been on the work since more than about 9 centuries. It is not new. Yes, 9 centuries. So it has been on the way, on this how things were done. And today, when I teach my astronomy course at the end of chapter 1, I have this, not exactly the same slide, but I have this, the scientific method, how to do it. So this existed. So it is not something that has been put into perspective in the 19th or maybe 20th century or the 21st century. It exists in the 10th and also in the 11th century. This is very, very important. The peer review process, I talked about it. Here I'm just mentioning what they were doing in medicine. You have this is what you call the ethics of the physician. You have someone sick, so the physician is going to see him or to see her, and there's a local council, local medical council, to check that what has been prescribed for the sick is right. So at least he can or she can follow the right medical treatment. So this is very important. And if, look at it here, if the review of the committee is bad, so something is going to happen to the so at least to avoid lawsuit and so on as we have it so this peer review did exist, at least in medicine. At least it did exist in medicine. Okay, so now what did push the Islamic science? Here I'm emphasizing on astronomy because I am an astrophysicist, and Andreas same. So we'd like to advertise for our knowledge. Okay, so our daily lives as Muslims is tied to something that we need to do to be called a Muslim. I believe that's nothing special about it, especially the beginning of the Islamic month. But you know, just to joke about it, we as Muslims, we don't give a damn about any other month, except what? Except Ramadan and Dhul Hijjah. Sah. This one, mashallah, everyone. We have 1.7 billion Muslims. By the time of Ramadan, by the time of Dhul Hijjah, 1.7 billion, no, let me add, 1.8 billion astronomers. Good. Everyone now is becoming knowledgeable about when to start the Islamic month, because we use whatever. There's a long story about the Islamic month, the visibility of the crescent and so on and so on. It goes back to whatever. Okay, the determination of the Qibla, the prayers. Let me give you a story. It is not a joke, a story. I am from Algeria. One very rich guy, maybe in order to repent from his deeds, bad deeds, he said, okay, let me build the mosque for my small city. He did build the mosque, but without consulting the locals. And for sure, when you build the mosque, you need to have the direction of Qibla and so on. You need to do that. Well, he did it wrong, and no one knew about it. For 2 years, they were praying towards Spain. Do you believe that? That's why it's very important to ask. Time dimension of the 5 daily prayers, for sure. Now we don't put it as a stick and we follow the shadow. No, for sure. We know because it is related to the motion of the sun. We know it. So we can do it. So everything now is digitized, mashallah. But these were basic questions for whom? For the early Muslims. There were big problems, yes, to set up the direction of Qibla and to set the daily prayer times and so on. So it was a big problem. So because this is what you call the major import. Those things that did push the development of the Islamic astronomy because of this concern, because especially about this one, the start of the Islamic month. And it was not a new problem. So even the previous civilization did face the same one. The Babylonians, they did also had a lunar calendar. The Jewish, they had this lunar solar calendar. So even then they did face this problem of defining the beginning of the month based upon the moon. Okay, so they have, for sure, they have so many criteria, like 24 hours, like the moon has to set 40 minutes after sunset, and so on and so on. And these were not simple astronomical problems. They were very difficult, yeah, especially for the beginning of the Islamic month, and also to be able to find the beginning to figure out the beginning of whatever. Now, major schools of mathematical astronomy. Here I'm going to go a little bit technical, and I apologize for that. Here I'm going to list, I don't remember, 4 or 5, I was going to see that. Okay, so 5 of them. For sure there were, as I said, every city was a center of knowledge. Okay, here I'm just emphasizing on these 5 because they did work out what you call the mathematical astronomy. The one that did have to develop so many good theories. So the school of Baghdad, the school of Cairo, Al-Qahira, the school of Al-Andalus, the school of Maragha. Usually I joke about my students. Okay, can someone tell me the location of Maragha? Maragha ala طول Morocco. No, ya habibi, it's not Morocco. Maragha is not Morocco. Maragha is it is there. It's close to us. It's northern Iran, Shamal Iran. Maragha. It's good. Maragha, Morocco, whatever we can, whatever. And also the school of Samarkand, mashallah. So if I may start, the school of Baghdad, Khalifa al-Mansur. So every school had its own contribution. It's not because I say the school of Baghdad, the school of Cairo, no, and all they worked together for sure, because even though the knowledge was not easy transmissible as it is today, but they had some connection. So under Harun al-Rashid al-Ma'mun, the school of Baghdad produced its more important work. Here, the old theories were revised, especially Ptolemy errors. When I talk about Ptolemy errors, I may talk about the model of Ptolemy, because in the early days, so everything was geocentric. Earth was the center of everything. And the sun has to go around us. The moon for sure has to go around us. But everything goes so it's like geocentric. And it took forever to change this. And for sure, for the Greeks, they have to save the phenomena, as they usually say, to save the observation. That's why they came up with this model in which Earth is the center of everything. And for the Greeks, everything should go around in a beautiful circular orbit. The Greeks did not like any other shape except the circle. I don't know, they were obsessed with the circle. So the moon has to go around us, around the circle. The sun has to go around us, around the circle. This, what you call this, is the Greek model, this geocentric model. It took more than 5,000 years to change this concept. Well, some of them started to say, no, this secular motion is not acceptable anymore, especially Al-Battani, when he was able to check out the eclipses, the solar eclipses, he was able to observe this annular eclipse. This annular eclipse cannot be if the moon has a circular orbit around the Earth. If it had a circular orbit, meaning the distance between Earth and the sun is always the same. So the moon orbit around Earth must be elliptical. And if it is elliptical, it can be close, it will appear big, it can be fast, appear small. And if there's a solar eclipse, it cannot hide the sun. And we have this annular Kusuf Halapi. Well, this is Al-Battani, yes. Even though he did accept the geocentric model, but in his lunar model, it was very different. There are so many things here, but I won't go about it. The ecliptic obliquity. How to explain that? So if I may ask a general astronomy question about the seasons. Okay, what is the main cause of the season? Is it how far away we are from the sun? No, it is not. How far we are from the sun? Winter time, we are closer to the sun than summertime. But winter time is cold. Alhamdulillah, it's cold these days. That's why we have this. We thank the Professor Masoud for having this school in winter. You saw some rain yesterday, no? We're flooded. Someone went to Ibn Battuta Mall. I don't know if you don't know Ibn Battuta Mall, just at the end of Dubai. And Ibn Battuta Mall was flooded. They believe that was flooded because we are not used to rain, to heavy rain. We see it from time to time, but that's good, mashallah. So in terms of the season, okay, so the how tilted is Earth orbit? What do you mean by how tilted? Well, Earth, for sure, goes around itself. We define its axis of rotation. And also it goes around the sun. We define its axis of revolution. Between the axis of revolution, axis of rotation, we have this beautiful angle, this obliquity, 23.5 as it is now. But it is not fixed. It does change. So Battani, by the way, was the how to say it, was the most experienced astronomer in Islam in terms of observation. And he was using what? He was using some tools that we call today primitive tools, but for him there were, I believe, everything. We can compare Al-Battani to the Hubble Space Telescope without having a telescope. This is Al-Battani. The exact duration of the solar year, Al-Battani, what do you mean by the exact duration? For sure, he did believe in the geocentric system. He still see the Earth goes around, the sun goes around, but he was able to define how much time does it take that. If we compare the time of the solar year of Al-Battani to Ptolemy and to the present one, where Al-Battani was closer by 2 minutes, 22 seconds. Ptolemy was far away by 6 minutes and 14 seconds. Why? Because Al-Battani was a very, very keen observer. Yes, a very keen observer. Prediction of the solar lunar eclipses, theory of the lunar eclipse and visibility, but this is very important. Al-Battani Zij. Zij is some kind of astronomical handbook. There are some Zijs. For every city, it has its own Zij, because for every city, it has its own sunrise, sunset, moonset, prayer time, prayer, whatever. But Al-Battani Zij was very important. It was used until the 19th century. Very big book. It has everything. Sunrise, sunset for the sun, sunrise, moonset, moonrise for the moon, the major stars, the major planet, the 5 naked eye planets, the prayer times, everything. Very, very big books. Very big books. So this is what did differentiate the Baghdad school from the other schools, and the credit they go to Al-Battani. Al-Qahira. Ali ibn Yunus, very famous Egyptian astronomer. He made what you call the pendulum. The pendulum is a very simple device, just a rope and a mass, and it will swing. Well, the number of swings is time. And in astronomy, if you do an observation, if you don't report the time, the observation is obsolete. Khalas, that. You need to report the time. And also this solar quadrant, a quarter of a circle. It has so many uses. I used to give my student to a sheet of paper with a design to make a solar quadrant to measure the time during the day, because it is based upon the sun. Another book, look at it, Al-Hakimi Zij. It was Nisba, because in the old days, whenever you write a book, you need to name it after the ruler of that city and so on, Al-Hakimi Zij. Very, very important book, because it did report more than 100 solar observations, especially of the eclipses, planetary conjunctions. Besides Ali ibn Yunus, we have also Ibn al-Haytham al-Hazm, part of this school also, and his work in optics. And as I say, so the work of Hassan ibn al-Haytham were the basis for Reggie Bacon, also Kepler. Al-Bahaniqi, Kitab al-Mabadi of Abu Ali Marakushi, which was like some kind of a mathematical geography, as it was mentioned by George Sarton. So these are just some major work. Yeah, I'm just trying to figure these are the major works and the most important one. The School of Andalus. The early Muslim astronomers, they did accept the Ptolemaic model without any comment, accept it as it is, this geocentric system, Earth at the center. Then started some criticism about it, because this model was not able to explain some observation. While the model of Ptolemy did try to explain, especially if I may give just this example about planet Mars, the red planet, and its retrograde motion. What do you mean by that? If you observe Mars over the course of time, you see it, let's say, moving from right to left, then it will change from left to right. This retrograde motion did puzzle the ancient. How to solve it? Well, Ptolemy found a solution. Having Earth at the center and having planets going around, but that planet does not go around directly around Earth. It uses a small circle called epicycle. The center of that epicycle goes around Earth, but the planet goes around this small circle. By doing so, Ptolemy was able to explain the retrograde motion of Mars. Hoorah, mashallah. But he added a circle for every planet, and his model became very complicated. Who dared to change this complicated system? Because having these cycles, it took some time. While by putting the sun at the center and having planets going around, there were no need for these epicycles. Khalas, the problem was solved by Copernicus. Even though in the early years, Copernicus did kept this uniform, this circular motion around the sun. You had to wait for Kepler to make the change to have these orbits elliptical, not circles. So there was some criticism of certain defects. So as I said, at the beginning, they accepted. Then there were some critics. Then the whole thing was changed by Ibn Shatter, but this is a historical argument. We don't have that book where Ibn Shatter showed his Copernicus model. Maybe Qawsin. Okay. New methods for finding the eccentricities and direction of the abscissal line of a superplanet by Jabir ibn Aflah. These are some details. I won't go. I won't go into them. The measurement of the astronomical twilight to be 18 degrees because we have different twilights. We have the civil twilight, we have the nautical twilight, and so on. I won't go into the details and so on. Okay, so these are just the major ones that are very, very important not to forget. The school of Maraga, as I said, not Morocco. So this is start with Nasruddin Atosi. He was a scientist, polymath, and also he was a politician. Very, very keen politician. So he was able to build this Maraga. It is said that it is because of this Maraga observatory that the observatory spread into the Islamic world. But most of these observatories, they lived a very short lifetime because they were built at the beginning to do one thing, to do astrology, Tanjim. And if that astronomer does something bad in terms of his astrological or whatever conclusions, he may be killed, and for sure the ruler will order the demolition of the observatory, and maybe he will burn all of the books. That's why most of the small observatories, they lived a couple of months, maybe a couple of years. Only very few, like this one, Al-Maraga, lived about 12 years because the one who did build it is a scientist, Nasruddin Atosi. So it was like a school, this Maraga Observatory, and for sure it did influence the observatory of Samarkand and Istanbul, and also those in the West. And like Baghdad, with what you call the Al-Battani Zij, like Cairo with Al-Hakimi Zij. This one also has its own book, Al-Khani Zijan, displaying the result of 12 years of observation. This Tosi couple is very, very important in terms when you understand the motion of planets. So there were some tries to change the Ptolemaic model, especially in this Tosi, as I say Tosi, but I speak Arabic, a Tosi couple. So a planet going inside a planet. I won't go into the details. So the major work of this school, so I'm sorry, are this. Okay, we go to School of Samarkand. That's a very special school, but why? Because it was like a university where students will come and will study every type of scientist. And Qadi Zada and Olobir, he was the one who was selecting the teachers because he was a scientist. Qadi Zada Rumi came here to be also part of his team, yani. And the observatory of Samarkand lived for 20 years. And what is good if you compare the measurement, and this is very important. If you compare the measurement of what we have today of Saturn, Jupiter, this was very close to the measurement of Samarkand. Why? Because the Samarkand observatory had a very big quadrant, 40-meter diameter. Today we say in astronomy, bigger is better. The bigger the instrument, the better are your results. So this concept, bigger, did exist in this 15th century astronomy. That's why so the motion of Saturn and Jupiter were very close. Look, 2 to 5 seconds of those of modern times. And using what? As we say today, using just primitive instruments. Al-Kashi was able to compute these 2 pi to 16 decimal places, the value of the sign. I did not talk about Al-Battani contribution because Al-Battani was the first one to introduce the sign. The Greeks, they did play with angles, but they use arcs. And that's very, very different from the sign and so on. So most of the mathematical trigonometric functions are from Al-Battani. He did develop them. So many things to say about it here, but let me leave it when we talk about this famous Muslim astronomers, Ptolemy model. This is the Ptolemy model where everything goes around Earth and so on. This is what you call the epicycle. This is just why did the Ptolemy add this circle? Because they had to explain why those mass goes and return back. So Now we know it because we have this heliocentric system. Because we planet Earth, we are planet number 3. Mars is planet number 4, and we follow physics rules. So we go around the sun much faster. That's why we are going to overpass. It is exactly the same thing. If you are in a highway, you have 2 cars. This car is slow and this one is fast. If you overpass the slow, if you look back, you see this one going backward. So exactly what's happening here between Earth and Mars. So it is like it has been explained just by using this beautiful. So without the need for this very difficult epicycle. So every outer planet like Mars, like Jupiter, does this motion, this retrograde motion, mashallah. This is same here, okay? The Copernicus model, mashallah, the sun at the center, everything has been solved, but still we have some problems. Here just to mention what Copernicus took as data, as information. It didn't have an angel coming from space and put it in his brain, this science. Well, he took his knowledge from whom? From Al-Battani, Nasruddin Tosi, and probably Ibn Shatter. This is the big question mark here, probably Ibn Shatter, because the model of the lunar model of Ibn Shatter is exactly the same as Copernicus model. When Ibn Shatter put in his figure Copernicus wrote B. When Ibn Shatter wrote Alif, Copernicus wrote A. So this is common. There must be something, whatever. Okay, so we leave that to time to tell the difference. Okay. Problem of the moon, problem of the upper planets, problem of the moon. So all of this have to be solved by the Copernicus or by the heliocentric system. The retrograde motion in the Copernicus system, this is what I did explain, so I don't want to go about it. I believe there is, if you click on it, there is a video, but okay, let's see it. Look at it. There is no need for epicycle here. The same movement will appear, but no need for epicycle because we are planet 3, Mars planet 4 is slower. So Earth is going to overpass. That's why we have this the same motion. So this is planet Earth. Sorry, it is green. It is green planet, yes. And this is planet Mars. So there is same without having this epicycle. So the model became quite simple. Al-Battani, so these are some details that I have talked about it. Okay, some of the instruments that were used by this is what you call the solar quadrant. This is a brass one. Okay, this is a very simple method for my Al-Battani to find the Qibla direction. Okay. Do you want to see it or pass it? You see it? You insist? Okay, you insist, we'll see it, inshallah. Okay, so you draw a circle, or you know your city, you know the main direction is Mecca al-Mukarram. We know its longitude, we know its latitude. This is how we define the location of any city. I believe here I give an example, Paris, maybe, I don't know, I don't remember that. Maybe Paris, or maybe Cairo, maybe Zakazek, whatever. Zakazek is a city in Egypt. Do you know that? Huh? Yes, alhamdulillah. Okay. My grandson is from Zakazek. My daughter is married to an Egyptian. Good or bad, I don't know, whatever. Time will tell. Okay, so this is Mecca al-Mukarramah. So I would like to find the direction of this following Al-Battani simple method. So this is for Paris. Okay, yes, for Paris, I am right. So we know Mecca al-Mukarramah. We know Paris location. Okay, by latitude and by longitude. Okay, so what we do? We build a circle here. Here it is. So just take the difference between the latitude of the two cities and the longitude of the two cities. This is a Battani method. That is not my method. This is what he did. Very, very simple one. So we draw the city. This is for Mecca. This is the location. Look at it here. So this is north. east, west, and south. Okay, so the direction of Mecca Mukarramah, and for Paris, we do. I'm sorry. We do the difference between the latitude of Mecca and Paris, and the longitude of Mecca, and we find the crossing point is just, you do this difference, okay? You do, I'm sorry, do this difference and also this difference. So you get a negative value, and this would be Mecca Mukarramah for your city, for Paris. So you do the same thing for any city worldwide. Okay, Al-Biruni, as I said, the mass of all master. This is just a manuscript showing just the phases of the moon. Al-Biruni method to measure Earth circumference. There are so many details here, so I will pass by. So at least its value is not as we know it today, because he did assume that Earth is a perfect sphere, and Earth is not a perfect sphere. It is a little bit oblate. If you measure Earth diameter along the equator compared to Earth diameter along the poles, the one along the equator is longer by about 17 kilometers. Okay, Ibn Shatta, that's very, very important for us. Why? Because there is still this problem about the model of Copernicus and the model of Ibn Shatta, especially in terms of the lunar model and so on. This is the lunar model. This very good thing from Kennedy. What is of most interest, however, is that Ibn Shatta lunar theory, except for trivial differences in parameters, is identical to that of Copernicus, point by point, except with this this is the model of Ibn Shatta. There's also something very important about Ibn Shatta model, is his sundial. Al-Mizwal al-Shamsiyya, to figure out the daily times of the prayer and so on. What is very important about the sundial because sundial is when the sun is up. But even this one, if the moon is full, you can use it. It will also cast some shadow, especially for nighttime prayer. That's why the Ibn Shatta sundial is very important. If you visit the Umayyad Mosque, you can see a replica of it. Do you know a replica of it? We knew about it only about maybe 20 years ago. That what we have today in that Umayyad Mosque in Damascus is not the real one. The real one was broken, because the ruler of Damascus during that time asked some astronomers to clean it up, and they broke it. They were so afraid that they made a replica, but the king or the ruler knew about it later on. So now what, if you have to visit the real one, you go to the museum of Damascus. Okay, so it is here. It is here, this sundial, and this is how it looks like. This is the broken one. Okay, not the real one. This is the solar model of the Shatta, also about the Tosi couple, whatever. Nasruddin Tosi, this great scholar, and so on. What you call the Tosi couple. Here it is, two circles going around each other. Copernicus and Tosi. So even Copernicus did mention a Tosi in terms of this Tosi couple to explain the motion. Doubt about the Greek astronomy. Every Muslim astronomer that came was building his doubt about the Ptolemy model, starting from Al-Battani to the later astronomy. But because the Ptolemy model was so complicated, by introducing these epicycles to explain the retrograde motion, very few dared to change it. So we had to wait until we get to Ibn Shatta, and also to Nasruddin Tosi with his Tosi couple. So this is what we call the beginning of the new change, to have a new system to explain what you call the celestial order, because by putting the sun at the center of the solar system, it was a very big relief. Because before you were like, Earth is everything. It's like some kind of a complex in our brain that we are everything. By putting the sun at the center, we liberated ourselves from this geocentric system. Then is our star, the sun, the center of everything? No, it is not the center of everything. It's just one star among hundreds of billions that make this beautiful galaxy we call our own Milky Way galaxy. Is our own Milky Way galaxy the only galaxy? No, we have 2,000 billions, 2 trillions of other galaxies, and each one of them we have between 50 to maybe 500 billions of stars, and maybe around each of these stars we have 5 to 10 planets. And if you multiply all of these numbers by themselves, you can imagine how many planets do we have in this whole universe. And you may ask also yourself at the end, a very intelligent question: is Earth unique? Are we alone? This is the ET theme. Are we alone? Is Earth? Well, it all depends upon how you answer this question. Is life that you know based only upon water, or maybe upon something else? Well, as far as we know today, Earth is based upon, life is based upon water, but not any type of water, only liquid water. And as far as we know, and maybe Dr. Andreas may agree or may not agree, as far as we know today, this liquid water exists only here. You can see it, here it is. No, for sure it is only on planet Earth, because we have the right mass, we are at the right distance from the sun for this water not to evaporate. If we are very close to the sun like Venus, it will evaporate. If we were like Mars, it will become a sea of ice. So we are, there are so many doubts, so I will pass around. Here I will talk about it. I will just show pictures. Okay, so this is what we believe today. It's very important for us today. Bigger is better. The bigger the mirror, the bigger the telescope, whatever, the more light you get, and any type of light, the more light you get, and the more light you get, the better is the image, and so on. That's why we did send the James Webb Space Telescope, a 6.5 meter infrared telescope. Yes, at about 1.5 million kilometers, not like the Hubble. So bigger is better. BB. So a big building housing a big telescope. This is what we have today, mashallah, very beautiful. Well, did these two concepts, did they exist in the old age? Yes, they did. They did. Bigger is better, mashallah. Also, you need to have not only just a mirror to observe, for sure you need to have so many instruments with your system. Did this exist before? Yes, it did exist. Not only one instrument, so many instruments, as you can see here in this picture. A highly motivated research team today to do research, for sure. You may have a brain, but you may not have the tool. You may not have the observatory, the instruments. You need to be associated with the research team. Did this exist before? Yes, it did exist before. So here I'm building that this notion, that this modern notion that we have today, they did exist 10, 11, 12 centuries ago. It is not new. We did have them, yes. Adequate library, yes. Today, for sure, if you go to an observatory, it may be far away, it must have some books, because you may spend that 2-3 days. You need to read, you need to do whatever. For what did this exist before? Yes, it did exist. All of this, mashallah. Again, whatever convenient living quarters, you go maybe to a high peak, a high mountain. You spend maybe a week. You need to find a way what to sleep, what to eat, and so on. Did this exist before? Yes, it did exist. Everything existed, mashallah. That's why I'm saying here that the notion of the observatory started with the Muslims. It did exist. All of this is what we have today in our days, to have your observatory. Okay, the Islamic observatory. What is good that it was built as an institution. It was funded. That's very important to be funded these days. Okay. But as I said, they were short-lived. Why? Because of this astrological problem and so on. Some of them were built to do astrology, and if anything happened to the ruler, to the king, whatever. Here, a very important question: could the observatory be regarded as a true representative of an integral part of the Islamic civilization? And the answer is yes. Yes, because the Islamic observatory was used to define the beginning of the Islamic month, to define the beginning of the Islamic prayer. So it was an institution funded by the state. Yes. Some observatories, I won't go through all of them for sure. But the best one are this one, the Samarkand Observatory and the Maragha Observatory. This is the remains, Baqaya, Masjid Maragha. The Iranians, to save what was left, they built this dome to protect what is inside. Inside we have only ruins. صخور فقط. ما بقي شيء للأسف. So here it is, what the Iranian built, and this is what we have inside. Look, all of these instruments were inside. But look, mashallah, at the stuff. It was, yes, it was a scientific institution. ليس فقط شخص واحد, only one person. Very, very famous, ناصر الدين الطوسي, قطب الدين الشيرازي, المغربي, الأردي, القزويني, yes, mashallah. Look at it, this is Chinese scholar. They believe that international collaboration, mashallah. Kamaluddin al-Aiki was the main one responsible for the library. So it was an institution, mashallah, not only a couple of persons and so on. And look at the library, huge one, 400,000 volumes. So it was a real institution. Why? Because it was funded by a real scholar, Nasir al-Din al-Tusi, mashallah. Instruments, look at it, a list of instruments. For sure, for you, it means nothing, but all of these are very, very important instruments that were used to observe. This is just a broken sundial. The army sphere. It is like a telescope today. Look at it here. Look how big is this building. A couple of scholars working together. You see them? Look at this one, the pendulum. Very important to define time, because as I say, if you observe in astronomy, you don't report time, خلاص المشاهدة سوف تسقط. Look at this main circle, the meridian. Look at the ticks here. They were very, very precise in measuring angles. This is just what you call the horizon. And so many circles. Why? Because they took so many stars as a reference, especially the brightest one. For every season, you have a couple of them. Same here. If you go to Ibn Battuta Mall, you see it. You see this one. It is there. This is not me. This is my son. You know him, Ridwan. He's now married in Germany, Berlin. This is Riyadh, architect now. Oh, yes, meaning that I'm an old guy. And this is my daughter. She's now a doctor. It is an old image. This one I came here to the UAE. Unbelievable. Yeah, this one, this replica is in Ibn Battuta Mall, yes. If you go to the Egyptian court, you will see it there. Yeah, it is there, inshallah, yes. The Egyptian court is, see, this is the Egyptian court here. But yesterday it was flooded, I don't know, so I don't want to advertise for it. Maybe some people get that. Oh, whatever. Okay, so this is just how long it lived. Okay, I talked about it. Some important work, I talked about it here, so I will go over it, inshallah. Samarkand Observatory. This is what you call the jewel of all the Islamic observatories. Why? Because it was founded by Ologbir, who was a scholar. And his grandfather is Tamerlan. Some of you may know about the Mongols invasion and so on. His observatory was sponsored by the state, and it lived about 30 years of active life. Do you believe that? Very big building. This is the remains of it. We think that it was like this one, a big building, so many windows because you observe from all directions, mashallah. So it was demolished, and as I say, 1971, this ex-Soviet scholars, they found it, they dig it out, and now you can visit it as what? You can visit so many instruments here, I won't go. This is a very, very big instrument, about 40 meters in diameter. You can see only 1/4 of it, and this, I believe, I did have an image. This is underground. This is facing south. Well, because Samarkand is north, and most of the plants will go over the southern sky, the southern horizon. This is this big quadrant. So the astronomer will come, and he will sit at different stairs to be able to measure how high, how low are these celestial objects, especially the planets. This is just to tell how big it was, and I believe I have, yes, this is a Soviet Union stamp CCCP, okay, 1987. This is Ologbir, and look at, so what is left is only this part underground. The upper part was destroyed or was demolished by Ologbir's son. The main instrument is Fakhri sextant and so on, other instrument and so on. This is the astrolabe. By the way, whenever people talk about the astrolabe, they think that it is a Muslim invention. No, it did exist before the Muslim. We brought some models like the linear astrolabe, but it did exist. The astrolabe is like a universal instrument. It can be used for anything, to observe anything. Some of them are very heavy because it's made of brass. Usually they have, if you go upstairs, we have some replica of it. It comes with 4 plates, and this can move out tens of lines, because for every season there is a specific star to follow and so on. So it is a universal instrument. You can use it to figure out the time of the prayer, the direction of Qibla, stars, and so on. So that's why every observatory has, this is a solar quadrant. This is just some typical picture. This is a Marag Observatory, 50th century. Look here, this is the what I say, so a scientific institution, a library, a couple of instruments, a teamwork all together. So this is very, very important. This is Istanbul Observatory. So many scientists, so many instruments, a library. So it is like a full scientific institution. We were good observers, so we observe and so on. There's just a picture showing a Muslim astronomer observing maybe a meteor, maybe a comet. So good observers and so on. The celestial globe. This is just part of what you call the one of the observatory of Istanbul. Some of the instruments being used to observe. Another instrument to figure out the direction of Mecca. The decline, what to say about it? You can say so many things. From the historical point of view, how the Islamic civilization started to disintegrate, okay? It started with the loss of Al-Andalus. Baghdad was attacked by the Mongol, and as you know, the Mongol became bitter Muslim later on. Look, so many books were lost when Cordoba was lost. So there was so many setbacks. This is what you call the beginning of the decline of the Islamic empire and also of the Islamic science and so on. By the 13th, 14th, 15th century, the Western civilization started to rise. And many thousands of Islamic manuscripts were now at the reach of Western scientists. So it was a common thing to refer to Muslim scientists, as so many Western scientists did, and so on. And then came what you call the colonization era. So the whole Muslim world was almost colonized by so many foreign powers, by France, by Britain, by name it, by so that's why everything went into chaos. That's why it is not so many of our manuscripts are now in so many Western capitals. Sometimes it's very difficult to see them, to study them, and so on. I remember in the 90s when I went to Algeria when I finished my PhD. So in the Algiers library, they have thousands of these manuscripts, and even in Algeria, it was very difficult for me to get hold of this manuscript. Do you believe that? Even as an Algerian scientist, because it was like, I don't know, it was like a state secret and so on. Because of so many reasons, as I did talk about them. This is a very bad number. 35% of the Muslim population cannot read. I have some old statistics, but I believe if you compare them to the new ones I did last night, I didn't find any difference. That's why I didn't change them. In terms of the literacy rate, country by country. I apologize if your country is listed here, but this is, you cannot hide it because this is the way it is. So if we go by male, you can take a look at the countries in which the literacy rate. So some of them are very bad. Look, Afghanistan, I believe. This for male, if you see female, I believe it is a disaster. It is a disaster. So whatever. So and you can check this this link. This is very important. nationmaster.com. It will give you all the statistics. All the statistics. This is for the male. And look at the female. Here it is. Look at the Afghanistan, 12.6. I believe this is 2000. After 2 decades, it didn't change. It is worse. It is worse. And the average is about 67.6%. Look, in terms of women. And for sure, Islam is innocent. It's innocent. It never said that women cannot go to school, cannot reach university, or cannot. It is only about it is only our traditions, our ignorant tradition that are imposing these things today. 67.6% compared to male. Look at it, male 80.5. These numbers are old, but as I said, I checked yesterday this site, it didn't change a lot. Maybe by maybe 1.5%. So that's why I kept it as it is, mashallah. So how to revive? What to do? For sure, there are so many things that can be done, and I believe that every one of you believes that things have improved. I believe now you go to any Muslim country, you have hundreds of universities, you have, mashallah, hundreds of scholars and so on. So things have improved, but for sure the change cannot happen within 1 or 2 or 3 decades. It takes centuries for the change to appear. Yes, there is some kind of awakening, but this awakening is going to take time to happen. If I take as an example, I believe you are here in the UAE, the United Arab Emirates. For sure, I came here in 1997. If I compare 97 to 2023, unbelievable. A very, very big change. Whenever you go elsewhere, In the West, okay, they do not know the UAE. You see, I am from Sharjah. Who is Sharjah? Al-Shariqa. But if you say I am from Dubai, oh, I know Dubai. But Dubai, Shariqa, same. So things are changing. And as I said, it will take time for this revival to happen in all sciences. Alhamdulillah, we have this academy. Alhamdulillah, we have tens of universities in the UAE, and they're doing their best to put the UAE on the map. 2 years ago, we had the Mars Hope mission. This spacecraft is still now going around Mars. Now, at this moment, now we have this lunar rover, Rashid, toward the moon. Hopefully, it will arrive late April. Just last week, the Sharjah Academy, we sent our satellite to space, mashallah, and we're building the second one, alhamdulillah. So things are changing. So we are putting ourselves on the map. But as I said, the result, you don't have to wait for it. Someone else will let you know that, yes, there have been an awakening, and it takes time to. This is also very important. Politically speaking, this is all very, very important. You don't see that real cooperation among all of these Muslim countries. In some special cases, it does happen, but it is not spread or over. And that's also something that does refrain this awakening. Okay, yes, we have this, I don't know if some of you are members of this Islamic organization, I don't know. They only get together when Ramadan comes. Well, because for them it's only about crescent, about fasting. No, it is more than that. So Ramadan is only one small part. So we need to generalize all of this cooperation and so on. So this is what I was saying. Nothing in the teaching of Islam, nothing contends against learning, against science, against technology, or let me add something here, against women. Okay, and the pursuit of knowledge and scientific research is the right of every Muslim woman and every Muslim man. Alhamdulillah, we believe into that, because in some part of the world they take this against the Muslim. Oh, you're a woman, you veil them. You veil them. This is against humanity. Oh, you Muslim, and you are very strict in terms of women rights and so on. Yes, you may know that in some part of the world, this is not new. In some part of the world, they are writing some laws that it will be forbidden for you as a father or as a mother, I'm speaking in French, to set the sex of your baby or to give it a name. They said when he become old enough, he will choose his own sex. Do you believe that, Yani? A minority out of 8 billion people would like to change the whole concept of humanity. Well, this is not right. Me as a Muslim, this is not right. If it is right for you, it's on your business. For sure, I won't go to hell with you. Some steps that may help us to revive our Islamic identity, especially our Islamic knowledge. Aim at applying science and technology in the building of a new Islamic civilization. This is what we are doing, alhamdulillah. Train our religious scholars in basic science. Unbelievable. This is a big problem. I remember in 2017, we were invited with Professor Hamid to go to Mecca to talk about the beginning of the Islamic month, Hilal and so on. And one religious guy, from the beginning, the first minute, we don't believe in astronomical calculation. So, in the whole world, why did you bring us here? Wallahi, we don't believe in astronomical calculation. ليش أتيتوا بنا هنا؟ Why are we here to talk about it? خلاص ما شفت. So some like this, like that guy here in Sharjah when he talked about how does Earth rotate. Yeah, عجيب. It was a joke on CNN. It was a joke on CNN. Well, you know, sometimes it takes just a little bit of time. So no one answered him. But after 2 or 3 lectures from astronomers, he understood things. Yes, because he was in a black box. He doesn't know what to say. You have to let him know that here it is. We are not inventing things. People, they know how the moon moves around Earth. They know. So he understood by himself that yes. Now we are not saying we want to Mecca, not to say want to start Ramadan, but to think about how to be able to define the beginning of any Islamic month. What must be the scientific criteria? This is very important. So there are so many things. I won't like to read it. Whole national, alhamdulillah, we are doing that. Alhamdulillah, we are doing this. You are here, mashallah, alhamdulillah. We are exchanging, alhamdulillah. So I believe this is it. I don't know if this is the last slide or not. Let me check if this is the last slide. Oh, yes, conclusions. There's the last slide. Sorry. I finished. Thank you very much. Any questions, please? Yes, please.
We can name them as they, at the same time, for sure, the lecture was concentrated on astronomy, but all these scholars you mentioned actually contributed to the clinical psychology or Islamic psychology, because you said that observation is very important.
Yes.
The psychology scientific method is an introspective method, which is observation. So can we say that all these Muslim scholars you mentioned contributed to the Islamic?
Yes, yes, as I said, so this polymath, well, as you said, right, I did emphasize on my field of study, but you go to every field, you go to medicine, you go to physics, you go to engineering. So this philosophy of applying knowledge everywhere did exist at all levels, not only from my point of view, from my astronomical point of view. Medicine, for example, I talked about this peer review process. Yes, so they need to check out that the physician is giving the right medicine to the patient and so on. So it did exist at every level. Yes.
We can expect from this Muslim scholar all things to the psychology.
Yes. Just one point when I talked about the concept of the observatory. I wrote the modern concept, a big building, a big instrument, large number of scientists, a large library, and so on. So all of these concepts existed in the 11th, 12th, 13th century. They did exist. Yes. So it was something that that is not new to modern science. It did exist, but we tend to forget this, and we tend to take the Western new awakening as what you call as the guide. What this Western awakening, if it were not for the Islamic civilization, it would not have happened. I believe I give to Alia 2 of my papers when I talk about this. If it were not for the for the Islamic civilization, there will be no Western civilization in terms of science. And if it were not for the Greek science, there will not be any Islamic science. And if it were not for the Babylonian science, there will be no Greek science. So we go after each other. This knowledge is not the knowledge of one race, one country, one people. It is a knowledge of everyone. It is universal. And this is what the Muslim did understand. Beit al-Hikmah, so it was like a universal, universal institution where scientists came from all over the world, not only Muslim scientists, even some Jewish, Christian, they all worked under one roof, the roof of knowledge, the roof of science. It is universal. And this is exactly what you are seeing here in Dubai, I believe, these days. More than 190 countries all together, working together. Antonios, Dr. Antonios is from Greece, mashallah. Dr. Andreas is from Germany, so you are from different countries, mashallah. So this is multi-international. Yes. As we say, one hand cannot clap. You need two hands, all together, to do things for the better of humanity. Because when you go to space, you look down at Earth, it's one word. Space for all, as we say. Space for all. Yes, please.
In this direction that religious scholars should science in basic sciences. It's a right idea. In our Kerala, India, there are halaqat of durus in masajid. There has been taught the kitabs of kitab Risalat al-Mardini and Tasrih al-Abdad, and the scholars can find out the directions of Qibla and such kinds of things. In Kerala, it is happening.
So it is happening in India, but you need also to go deeper than that. That's why, so science, basic science, I believe, I don't know how to say it. I believe now up to high school level, every student, as far as I know here in the UAE, is touched by science. It's very important. By the time you graduate in high school, you have a knowledge of science. Then when you go to the university, it depends which field you will go. Because, you know, we have, as far as I can say about my country, Algeria. Sorry if I say that. As far as I can tell, in Algeria, those people who go to the religious studies are those people who fail high school. You know? Or are those people who don't have that great background in science. They fail math, they fail physics. Where do they go? Okay, go to religious specialty. This is what we have back home in Algeria. I don't know if other countries have the same thing, but this is what we have, and that's too bad. By the time this person, let's say, it does reach the level of being, let's say, an imam, he will have no knowledge about science. He's going to say something that has no meaning in terms of science because it doesn't have that scientific background. And that's what that Saudi scholar, he said, I don't believe in calculation. And at the end, he said, okay, because he was convinced by 3 or 4 astronomers when they lectures and so on about the motion of the sun, about the motion of the moon and so on. So he did see, yes, there is something right. Yes, I agree with you. Yes, some of us are ignorant. Yes, in terms when it comes to religious observances. Yes. Except me, yeah.
In accordance with the scientific method, there's a saying that great detective is a universal Islamic inductive system. That the differentiation between detective system and inductive system. Because Islamic scholars develop the inductive system, while in Greek civilization there is is right astronomer and mathematician who introduced the experimental methods in agricultural sector and in other areas. And how can we justify that Islamic scholars have introduced the experimentation method?
Well, I showed you in several slides the method, the Islamic method. What did al-Battani do? What Ibn Haytham did, and so on. So this is just what you call the experimentation, so to experiment in your field. For sure, for every field, it has its own plus, its own negative. But what I showed you in so many cases, how did the Muslim astronomers approach things? And that's very important. Al-Battani did it. Al-Khawarizmi for sure did it. I listed, I believe, also, I forgot his name. So every Muslim astronomer had his own approach about applying experimentation, especially when it comes to astronomy, because astronomy is based upon observation. You observe, and from your observation, for sure, you come up. Why did al-Battani refuted the model of Ptolemy in terms of the moon? Because al-Battani was able to see this annular solar eclipse, and it cannot happen if we follow the circular motion of the moon as set by the Greeks or by Ptolemy model. So observation to the rescue. So your observation of an event is going to change for sure your theory, and this is exactly what we do in scientific method. So you have a method, it will predict something, and the best way to do is to go and check these predictions. This prediction may fall upon your observation, meaning that you're going to observe this prediction, and or maybe you're going to observe nothing, meaning that your theory needs to be tuned. So you go back and change something and do the same thing to also predict something, and you go over and over and over. This is the scientific method that we follow today. And that's why whenever you send the paper for publication, it will pass to two, three, maybe 4 reviewers, and those reviewers, each one of them is going to tell you that this method is right or this method is wrong, and you have again to rewrite it. Yes. Yes, please.
One problem we had with actually Islamic educational system, when you read, for example, the life of Ibn Sina, that he describes the education he received and the curriculum that's established, is mainly, at the higher level. But at the specialization level, things were very weak. It was always private. Someone who gets, say, this Sharjah, look at the curriculum that we study, mainly the religious sciences that and so on around. They had later on added logic, some of the sciences, but not physical sciences as we know it today. If somebody had the Sharjah and wants to learn physics, specialized, he needs to do that. He has to find private teacher to teach him. It was not institutionalized.
Yes.
If it's not institutionalized, then you don't have the scientific mentality to produce more works in these physical sciences. This is extremely important. In the West, they were able to achieve this. They institutionalized, and therefore they started doctorate level. But we were very weak in this respect. I think this is also should be considered.
One negative point.
Right.
Yeah.
That at a certain point of history, disciplines which we call STEM, chemistry, mathematics, others, were removed from the curriculum of the madrasa. And in the beginning of the 19th century, Jadis in Central Asia insisted to add them again to the curriculum of madrasa.
Actually, it was never included in the curriculum of madrasa. It was always private. Because there are, in the past, there are great scientists, like Baftani and all these that you have mentioned, they studied privately.
Yeah.
They were not taught in the madrasa.
Yeah.
Madrasa was particularly for religious studies. And that's
Yeah,
it.
yeah. Well, things have changed now, I believe. So
And
now,
that's why, you know, that study that you, I don't believe in mathematics calculation.
yes. Yes, well, it is waning. It is not gaining momentum because now with what we have as new technologies, as social media and so on, so people are more awake than let's say 20 or maybe 30 years ago. So things now, knowledge is widely spread because of these new technologies. So maybe it was restricted in some part of the world earlier, but now it is spread with the internet and so on. Everyone can learn by his own, her own, whatever subject. So and this lecture is being broadcasted through Zoom, and I believe it is now being seen in so many different countries. Well, this did not exist. So things now are improving. But this new technological tool has only appeared in the last maybe 30 years or so. So it will take some time to be generalized, and hopefully, I don't know, one day will come where we don't need you to be here. So you because everything will be broadcasted and everything. So things will change. Things will change. So to the better of humanity in terms of the spread of knowledge. So now knowledge, and this will bring us another point, another that will be very, very hard, is how to control that knowledge from the good one to the bad ones. And this will be something very, very hard subject to tackle. So it needs big thinkers. Yes, yes, please. Just for the microphone, so that
therefore, our knowledge, this is everything. Therefore, I would like to ask you, this change can affect our Islamic civilization. Positive way or negative way?
well, it all depends, because as I said, knowledge is universal. It all depends upon how you're going to use that knowledge. Its use depends upon I may say upon your belief, because in my belief, so there is a knowledge that I am obliged to learn and so on, and there is a pseudo knowledge that I am not obliged to learn. For example, I choose between astronomy and astrology. So astronomy is the study of this universe using science, using physics, mathematics, and so on. Astrology is what? Astrology is the way you can play with the human mind to let him or let her know that the position of these stars can tell something about your future, which is completely wrong, because I am a Muslim. I don't believe in that. I don't believe. But for someone else who is not a Muslim, astrology is part of his life. He does believe in that, and we have some great personalities worldwide. They have great internet sites and so on, social media, and for them, astrology is science, is something that is part of their daily lives. So it all depends upon your faith, because knowledge now is so varied, so various. What to pick depends upon what you believe in. That's why giving a mobile to a 12 years old is a big problem. From my point of view as a Muslim, for someone who is not a Muslim, giving a mobile to a 12 years old, this is what you call freedom of choice. It all depends upon your faith. So, because you must have something to tell you what is right, what is wrong. And for me as a Muslim, what is right, what is wrong is my Quran and my Sunnah. Anything else? No. This is my reference, my two references, the Quran and the Sunnah. Anything else? No. If it has been made by someone, no. That's why I am an outlaw. I always fight bylaws. You go to any university, you have bylaws. Bylaw number 1, by who wrote them? Some people. They may apply to, yes, bylaws. We need to have some direction. صح. It is not a zoo, jungle. But sometimes some bylaws do not play into your way of doing things, and they may let you go backward. But Quran and the Sunnah, khalas, these are our references. No one is going to say because the Quran is not made by me, it is made by God, the Almighty, and the Almighty doesn't do wrong. If you believe so, khalas, it is your own business. It's the way it is. But sometimes some people don't want to say it, but this is the way it is. I am a Muslim, this is my references. The Quran, the Sunnah, anything else? If it does facilitate my way of life, yes, but if it does not, no, it is not, because it has been written by people. People can think, can do things wrong, but not the Quran, not the Hadith. You don't argue with that, صح? I am wrong. Alhamdulillah. I may be wrong, but not in terms of Quran and the Hadith. This is the word of God, period. Not like what Andrew Tate is saying. You know Andrew Tate? Good that you don't know him. Alhamdulillah. Don't know him. Don't Google him. Thank you very much. You're welcome. Thank you very much. Oh, yes. Yes.
Thank you, Professor Ilyas Fernini, for this beautiful lecture. We will continue after exactly 1 hour. We will continue with the next lecture. Next lecture is also very interesting. We included to our winter school this year. I was telling Professor Ilyas a while ago that, we do some 20% changes in our program, 2 years ago, we had psychology. Last year, we had economy and finance. And before last year, we had also arts. And this year, we did some adjustment to fit to the present winter school. We added heritage and mathematics. And our next lecture will be conducted by Professor Jan Hogendig from University of Utrecht, Netherlands, and he will join us online. He apologized because he had some other, he has been listening to all the lectures from the beginning. He was communicating now with me how he's hearing well the voice and how things are well. See you in an hour time. By the way, it is the topic is history of mathematics in Islamic civilization.